Good afternoon to you. Mark Sutton with HurricaneTrack.com here. Hurricane Outlook and discussion time. It is Monday, October the 12th. I am in Opelika, Alabama, the Auburn area. On my way back home to North Carolina finally after being on the road for several days tracking Hurricane Delta. What an experience that was. We will cover that over the coming days in more detail. And of course, next year in season 2 of the Hurricane Highway, there will be obviously an episode dedicated to that hurricane. First of all, just a real sincere thank you to all the people that supported this project, especially the new folks that signed up through Patreon to help crowdfund this effort. Don Moe down there in Sycamore Point getting the word out using Facebook and spreading the information, that we were doing this project and we got these live cameras that can help people to see what's going on. The only way that we can grow this and make it even bigger and have more cameras is to have more people involved. And that is the power of crowdfunding, and it worked very well. And it's not just the funding. It is the moral support. It is the physical help that people offer. It is the use of their property, things like that. I mean, look at Don, his house there, his camp in Sycamore Point. Advice on where to put equipment. The locals, etc. That's all part of that word, crowdfunding. The money is what helps to make the world go round. We all know that. And without the funding and the money, we couldn't do this. But it's the rest of the story that is really remarkable in the people that have helped out. So thank you all very, very much. You're the reason that we were able to be as successful as we were. And we learned a lot. We have some things we're going to try differently, and it's always a learning process. As I say, we move on to the next play. And that next play, well, we got to look ahead and see what's going on in the tropics. It is still hurricane season, and so here we are, October the 12th. Let's get to it and see what's going on out there. First of all, I look at the infrared satellite animation courtesy of Tropical Tidbits, and you look out at this time of the year, it's getting towards mid-October. We are in the last weeks of the hurricane season, but the Atlantic Basin, the Caribbean, all of this area through here is still very warm. The water temperatures are very warm. Generally speaking, there are tropical disturbances out there, tropical waves. Those are seedlings. And we have one such entity right there. Invest area 93L, that's lurking out there. There's more activity trying to brew off the coast of Africa. And then you got to watch these frontal systems that come through. Sometimes they leave a piece of energy behind out here that is able to congeal and come together. And you get these subtropical storms that usually develop out here somewhere, and then they move on out into the ocean. They can be closer to the United States and maybe impact Bermuda. You never know. I'm not as worried about those as I am that one of these systems here, one of these areas of energy, could make its way into the Caribbean where conditions become much more favorable. And really, that is the area, the Western Caribbean, that is climatologically favored this time of year. I mean, it's a pretty big area overall. It's not just this region that we worry about, but this is where some of the biggest impacts have come from, historically speaking. And so those are the areas that we watch the closest. We think about back in the past here, Hurricane Wilma, that originated in that part of the Caribbean. There was Hurricane Michelle, that was 2001, that originated in this part of the Caribbean, and they take different tracks. You just never know. In the case of Michelle, it developed and moved across Cuba and through the Bahamas, and it was a powerful Category 4 hurricane, I do believe, in the Caribbean, and it spared the southern Florida Peninsula and the Keys. But it didn't spare Cuba or the Bahamas, parts of the Bahamas anyway, whereas Wilma was a different story. Of course, this is an historic hurricane in the record books, and this one went on to impact the northeast Yucatan with severe hurricane conditions, and then a good deal of South Florida was heavily impacted by this Category 3 and eventually 2 hurricane. It was a 3 on the west coast, a 2 on the east coast. 6 million people, something like that, without power, and a very disruptive hurricane. And that's what we look for to see if that's going to happen this time of year. Florida is most vulnerable to major hurricanes in the month of October. It's true. It's by a slim margin over September and August, but it is October where you have the greatest chance of seeing a significant hurricane landfall, especially a major hurricane, Category 3 or higher. That typically happens more often in October than any other month. All right, so these are the areas that we're going to be watching. Again, there's Invest 93L out there in the open Atlantic, and I'll show you why it's not going to do much right now, but also why we have to watch it. And this is one clue right here. The energy here, the vorticity signature, there it is, very well pronounced. So there's a bundle of energy there. There's heat, there's moisture, there's spin in the atmosphere. The seedling is there, and it's a matter of what happens to it. Where does it go? Generally speaking, it looks like it's going to track into the direction of the Caribbean Sea. A piece of this energy on the north side might track through near the Virgin Islands, the Northeast Caribbean, maybe Puerto Rico. But the concentrated energy looks like it's going to move to the west-northwest into and through the Eastern Caribbean Sea, and then we're going to really have to watch it from there. And we know that the sea surface temperatures are still very much on the warm side relative to average. All of the Atlantic basin over here, with just the exception of a few areas. The northern Gulf, all the hurricane activity, this is left over from Paulette and Teddy, believe it or not. But man, everywhere else is running above the long-term average. The water temperatures are warmer than normal. And it is concentrated in two areas. One is the tropics and through the Caribbean down here. This area is very warm. I won't say very warm, but it's warmer than average. And then the northwest Atlantic, definitely warmer than average. And then there's this pocket here in the southwest Atlantic. So we know that there's plenty of heat available. We also know that there is a La Niña on the flip side, colder than average in the tropical Pacific, because the trade winds have been blowing through there stronger than average, kind of hauling the mail through there, upwelling colder water from below, and that has resulted in this anomalous cooling of the tropical Pacific. An anomaly is a departure from an average, or a mean, in this case, the average. And so these departures from average in the tropical Pacific are significant enough that we are in a cold ENSO phase. ENSO is El Nino, Southern Oscillation, and we're in a cold phase right now. It's a La Nina. Why is this important? Well, when this area is colder, you don't have as much upward motion over there, and it generally results in less wind shear cutting across the Caribbean. Doesn't mean that there's not any, but overall the average is less. You will have periods where there's high wind shear, and then you're going to have periods where there's lower wind shear, but it tends to average that we have less shear, especially over this area of the Caribbean, when we have a La Nina in place. All right, so now let's look at actual sea surface temperatures, and this came into play when Hurricane Delta made landfall just the other day, that we saw cooler sea surface temperatures up near Louisiana, which was good. Had Delta been a month earlier, which, you know, we certainly had the impacts from Laura, and it's hard to compare, well, what if it had been earlier? But had it been earlier, water temperatures would have been warmer, the shear probably would have been less, and we could have had a catastrophic hurricane. As it was, Delta significant enough. More storm surge damage down here in parts of Cameron Parish, and then east of there into where Sippermore Point is along the north part of Vermilion Bay. And then areas inland experienced a lot of rainfall. And anybody that thinks that this was a non-event and that it was overblown, I invite you to go to Louisiana and drive around and talk to people and get their opinion. They're not complaining, at least not to me. They're very resilient people. They're very tough, and they work together. But they do know that hurricanes impact them, and they know a solid hurricane when they see it. And, you know, this is on the heels of Laura. Bad timing, but they're going to bounce back. They'll help each other. But it was an impactful event, and it could have been worse, obviously, because the water temperatures were cooler. It was not worse, but it's still bad enough. We got to keep it into perspective here. So the area that we will concentrate on are, I don't want to say worry, but there is concern, because this is the time of year that South Florida can get hit from hurricanes coming out of the Caribbean. We know that. Cuba is the same way. They come out of the Caribbean and maybe cut across towards the Bahamas. And it's that area where the water temperatures are still very warm. These are actual sea surface temperatures, 28, 29, 30 Celsius. That means mid to upper 80s Fahrenheit. Plenty of warm water, and that water is warmer than the long-term average. If we look at the map here again, you can see positive sea surface temperature anomalies in there, meaning that they are warmer than the long-term average. Off the east coast in the mid-Atlantic, pretty sharp gradient here between the colder water right up against the shelf and the north wall of the Gulf Stream out here. Gradient in this case is the temperature difference over distance. And as an example, right here along Wrightsville Beach, we are talking about water temperatures in the low 70s, maybe even upper 60s. Kind of chilly. But just, a few tens of miles off into the west wall of the Gulf Stream, which is more out here, but the water temperatures go back up to 80, 81, 82, 83, which is nice. I miss that. But we know, looking back, other famous or really infamous Caribbean hurricanes, 2012 Hurricane Sandy got its origins from a system that came through, kind of turned, what did it do? It turned that corner and went up into New Jersey. I can't remember exactly. It was Cuba. That's right. It came across the eastern part of Cuba over here. Looked like it was going to impact Florida, and then it made that turn, something like that. So, yes, water temperatures matter off the mid-Atlantic and east coast. They are definitely cool and to cold, where I wouldn't go in. But you can still get hurricane impacts, even as they morph with extratropical and mid-latitude storms like we saw with Sandy 8 years ago. That is why we have to watch these disturbances. We see it on satellite. You see this impulse. Amazing to think that an impulse like this it might, you never know, small chance, it ends up being an historic hurricane later on. That is why we watch these. So speaking of watching, what's going on? Well, let's take a look at the GFS here. A pretty good indicator for genesis, the start of these systems. The European, the ECMWF, has been terrible at genesis this year, at picking up on the development of the hurricanes. It's just the way it is. The GFS is not fantastic. It's not perfect. And we're looking at this only as guidance. What is it showing? What are the numeric models indicating? These are our warning shots. These are our early, the canary in the coal mine, whatever analogy you want. We're just looking at this to see what might be coming. What does the guidance show? There's a lot of models. You got the GFS, you've got the Euro, the Canadian, the German Icon. You got the hurricane models. Once those get run on a system, the HWRF, the HMON, etc. It's just model galore. And then you have all of the ensembles. Plenty of models to watch. What I like to do is just kind of look for consistency and what the overall pattern is showing and see if it fits that maybe something could develop out of that pattern. Does it even make sense? So that's what we're looking for here. All right. So here is the impulse right down here that's 93L. And this is the 5,000 foot level of the atmosphere. We can see that at the 850 millibar, 12Z. That means it's initialized at 8 o'clock this morning. So this is the most recent run of the GFS. Believe it or not, this is some of the leftover energy up here from Delta. And this is a strong cold front coming through. This is vorticity that is stretched out linearly over the horizontal. What I'm looking for, as you know, is to see if something like this bundles into a circle or more spherical. If it's able to conserve that energy and bundle it around a warm core. And that's what we look for. That's what I look for. So that's the 5,000 foot level and various features showing energy with all the colors and then these different height lines of the atmosphere. Well, what about higher up when we look at shear? Well, 93L is located right in here. Okay, let's just go back. I like that we can go back and forth. That's where it's located. And you look at the lower levels here and you go, okay, there's some energy there. It's in the trades. Those trades are moving generally east to west. But what about upstairs at the 200 to 850 millibar level? So the difference between 5,000 feet and about, I don't know, 30, 40,000 feet, that layer, what's the wind shear like? Well, in here we can see it's blowing against, this is the system, this is 93L. The wind in the upper levels is coming against it. That's what we can see very clearly here in the modeling. Strong upper level winds are cutting across that system. So it's going to really be struggling to develop. And so keep that in mind as we go through. All right, so let's move this through. It tries to develop in the face of that shear just a little bit, and that shows me that it's pretty vigorous. And you can even see some banding in the shape of the vorticity down here. It's trying to develop. Maybe that shear tries to relax a little bit. This is 24 hours. Let's move this out to 24 hours. Yes, the shear does let up just a little bit right in there where it's located. So these are the very cool tools that we have to watch. Whether you are a meteorologist or you're just a weather hobbyist, we've got the tools to watch. Moving out to 48 hours, let's take a look. There it is, approaching portions of the Lesser Antilles. Well, what about at the shear level? All right, or at least between 850 and 200 millibars. Move this out to 48 hours. Shear's not as strong. You know, it's certainly, according to the GFS, under 20 knots or so. Why do we know that? Because here's the scale right here. It's in this color right here. So it's under 20 knots. All right. So then we just keep going out. Let's just look at 72, and it starts to dissipate and not become as organized. And we go to 96. Hard to really see where it is. The wave energy is in here somewhere. Let's look at the 96 hour of the shear, right? So yeah, the shear's definitely increased through the Caribbean there, and that explains probably why it's not as energized at this point. So let's keep going out to 120 and finally 144. This is 6 days out. And then finally at day 7. Now this is where I'm going to stop, because there's no sense even beyond day 5. So let's just look at day 7 and let's see what we've got. Okay? So this is kind of the end of the book for now, for me. You can go look at day 8, 9, 10 through 16 all you like. You just need to understand. Remember what Jules said in Pulp Fiction to Vincent? Remember that movie? Very vulgar movie. I don't expect that the younger kids should be going and seeing it, but there's this very famous line where he says to Vincent, Jules does, if my answers frighten you, then you should cease asking scary questions. I screwed it up. But that's the thing here. If you seek answers and you're asking the question of the GFS, what does it show in the long range? Be aware that the answers may frighten you, so to speak. And it's true. Do not get upset if you go looking at the long range if you don't understand that it's very long range and a lot can change. I caution you. You know, it's a matter, well, you can, but should you? So what do we see? Well, we see the bundling of a lot of energy down here. I can tell, looking at the model, we've got some broad rotation down here. The energy's trying to come together, kind of focusing the leftovers of that tropical wave. Maybe a tiny piece of it's broken off up here. The rest of it's ending up over here. Hard to say. But this is day 8 in the lower fields of the model, the 850 millibar vorticity. What about day 8 in the shear area? Let's move this along. All right, so here's where I do start to get a little concerned. Look at what is building down in the Caribbean. That's an anticyclone. All the red and orange and yellow that you see through here is extremely unfavorable. This, however, is very favorable and tries to develop even more so. And we know that because we look at the models beyond day 5, 6, 7, 8. We know. We see the evolution. I'm not going to go over it here because it's just a waste of time. But this is what I'm looking to see. Does this keep happening? And does it move up into the time scale? Tomorrow when I show this, that should be at day 6. And on Wednesday, it should be on day 5. And by that time, we might have a yellow tropical weather outlook issued for it, right? You understand? That's the evolution of how we do this. We don't go getting all upset. We don't go posting day 12 and day 14 deterministic model snapshots on social media. That's a big no-no. And people have done very well with that this year. I've hardly seen any of that. I'm not going to do it. I want to look at it in context because we're trying to learn, we're trying to stay aware, and we're trying to see what's possible for the future. All right, so that is the outlook part of this. I want to show you something real quick before I go. A couple of videos here from our mission into Delta. This is the time lapse that I did from the GoPro down in Grand Chenier. Set the GoPro up on the 8th with my team, Brent and Greg. This is facing west along Highway 82. Highway 82 is over on the left side. You might have seen this on Twitter. If not, here you go. This is a time lapse of several hours, and the wind is picking up. And the eye wall, etc., what was left over, has already moved through. And then the surge comes in behind it. And you can see it creeping in right there. And it comes in pretty abruptly at that point. This large rise in water off the Gulf of Mexico sweeps in, and it's got some velocity to it. We're only looking at about, I believe, 2 or 3 hours of time here, compressed down to about a minute and some change. So you see all the stuff floating by, all that damage behind there. That's from Laura. There was some wind damage, of course, from Delta, but the surge was pretty sweeping and massive in terms of the area that was flooded. 4, 5, 6, 7 feet. I wasn't everywhere. I don't know for sure. It wasn't on the high end. Some areas it was. We saw 9 feet at the freshwater lock, I think it was, or something like that, on a tide gauge. But just look, hours and hours and hours that it just kept flowing in, almost like a tsunami. It's not a tsunami, but it's that long push of water that Delta just dragged in. And that swept in for miles and inundated, lots of countryside there, and homes and farms, etc., in parts of Cameron Parish. And we've gotten to know a lot of people through it, and that's the positive. I've met some incredible people. Also, in Sippermore Point, off of Vermilion Bay, same kind of thing. The surge came in. It was a little later. This is over in the right front quadrant. That is Don Moe's house there, his camp in the background with the surge marker. But look, the surge comes in. It's gradual. Not much wave action here. The Atlantic, the open Gulf, it is different. You have waves on top of it. If the hurricane was stronger, you would have had waves here. If the surge was higher, you would have had waves, bigger than the waves you see here. Inside of Don's camp, the water level was about 5 feet, 3, 4 inches, something like that, in a still water mark. Unfortunately, it got dark, and we weren't able to see the peak surge in the GoPro video here. But it's pretty remarkable what we're doing with this technology. And again, as you know, I talk about it, because if I don't, it won't get funded. But this is crowd-funded science at work. This is what we do. And that is how you become, if I can highlight it, a part of it right there. And it's not too late. It's not just hurricane season. It's not just, buy a ticket to the movie and that's it. I want you to buy the movie and watch it at home, so to speak. That's the analogy. This is a sustained project, and this is exactly what we do with the funding that we receive. $10 a month. That's what we can do with it. Results. We have gotten results from the use of our technology, and as I said, the cooperation between us and some amazing people out there, in this case for Delta in Louisiana. Just truly remarkable. All right, that's it for me. Let me get this on YouTube and check out of the hotel here and finally get back home. Will I be on the Hurricane Highway again for Florida or somewhere else? Well, stay tuned. The end of that story has not yet been written. As always, thanks for tuning in. I'm Mark Sudduth, HurricaneTrack.com. I'll talk to you some more tomorrow.